Hello, everyone. In today's lecture, I'm going to talk about some introduction to signals and systems. So this is so important for autonomous vehicles because most of these vehicles, they are equipped with very high quality sensors. Those sensors gather information or signals from the environment, and those signals goes to the perception and control and decision making of the car, right? And in the following lectures, we'll talk about the sensors, we'll talk about the control system, and we'll talk about the communication systems of an autonomous vehicle. So the learning objectives of this lecture is to have some fundamental, where students will have some fundamental concepts of signals and systems, right? Will Student will be able to classify signals and as continuous and discrete time signals, identify real-world signals, differentiate between noise and disturbances, and explain what a system is. And eventually, at the end, you will have some basic like knowledge about how these signals and systems they are connected together. And then we'll talk about the applications in autonomous vehicles in the following lectures. So let's start with what is a signal, all right? A signal is the information that changes over time or space, okay? So mathematically, we write the signals as a function of one or more independent variables. Like for example, you may have a signal that changes with respect to location and time, or a signal that changes only with respect to time. And that location and time, they are independent variables. Okay. So here you can see that in this graph, in the figure, so we have an example of the wind speed changing with respect to height, right? This is an annual vertical wind profile. So signals are almost everywhere in our daily life. Like when you work with your cell phone, when you like the temperature in a room, the temperature in a city changes with respect to time through the day. So traffic volume on a highway is a signal. So you can represent it as a signal that changes with respect to time. So your voice when you speak, light intensity from a traffic light, okay? So that is also considered as a signal. So again, in autonomous vehicles, signals provide critical information for the control center of the car or brain of the car because they provide like in those information from the environment, what's going on around the vehicle. So this is exactly what's a human like in that happens in the nature, right? That um, even for the animals, right? They have those kind of the awareness systems that they make actions based on what kind of the information they receive from the environment, right? And like as an example of the human, when you drive in a highway, when you drive in a road, when you um, want to go to a certain location. So you are using the sensor that the human, like mainly, uh, like we use our eyes as a main sensors, which is like a cameras in an autonomous vehicle to get information from the environment, right? And see what's going on, and based on that, you make a decision if you want to go faster, if you want to move slower, if you need to push the brake, you stop because like some people like bike, human, or like animal is coming around the vehicle, right? So all these control, perception, they are happening based on the signals that coming through the environment. Now, in autonomous vehicles, there are multiple sensors that those sensors, they gather information from the environment. Um, Next lecture, I'm going to go over the details of which kind of the sensors they are mainly installed on an autonomous vehicle and how does those sensors work, what are the advantage and limitations, and how all these sensors they work together to help with the perception and control. So the signals in autonomous vehicle, we can talk about the camera images, LiDAR, point clouds, radar signals, vehicle speed and acceleration, and vehicle position, right? Which comes from the satellite through global positioning systems. Again, we'll talk about these sensors later. But these are the main signals that comes to an autonomous vehicle, and not just an autonomous vehicle. Almost in most of the even robotics application that we have, like mobile robots, small mobile robots. You may have seen like robot dogs. Um, so they also have like this kind. They also equipped with this kind of the sensors, which gather information and then do the analysis in the control center. So now, when we want to go to the details of what kind of the signal, we have different kind of two main types of the signals. So we have continuous time signals and discrete time signals. Um, Another name of continuous time signals, they are analog signals. They are actually a continuous time signal is a physical quantity, such as voltage or sound, that is defined for every instant of time. So I want you to be careful about like this term that we have the value of that signal in every instant of time. And it can be in a specific range. It can be like you can gather information about in a year, you can gather information in one day, you can gather information in one week. So it's based on the sampling. Like assume that you want to take information about the temperature of an environment only during the summer, or only in April, or only in one week in April. Okay, so that is what we have the specific range. So we normally represent the signal as x of t. So then x is that physical quantity and t is the independent variable, right? So and since it is an analog signal, a continuous time signal, that x of t is normally a smooth and analog function, and it has a value at every instant of time, right? And like if you take a look at this signal, so it is defined in a certain amount of time. So if you consider of between 0 and 5, okay, even between 0 and 1 second, you can have you have infinite number of samples of your signal, right? Because you can take the samples as small as like 10 to the power of negative 9 seconds, right? Or even with more accuracy. This is what we call it continuous time signal. So the other type of signals that we have, they are discrete time signals. They are the signals that they define at this certain time instance, all right? Or we can say that they are defined at discrete times. Like if you take a look at this example, this is an example of the stock market index, but it's in a weekly stock market index, like from 1929 to 1930. So every week you have sample of that Dow Jones stock market in every week, right? Not daily, not hourly. We have samples on every week. So those weeks, this is what we call it, they are discrete time, right? And that is what we have. We have these signals and they have their own amplitude or value. Now, we have a specific type of the signals that they are from the discrete time signals that we call them digital signals. Digital signals are discrete time signals that the amplitude of the signal is either 0 or 1. The signal doesn't have any other value. So if I get back to the like stock market example, so you can see that in a regular discrete time signal, you can have a variety of the amplitude, like even 200, 100, 300, 350, and 400. But digital signals, we don't have anything more than one. It's just 0 and 1. So why is this important? Because your cell phone, your computer, they have a central processing unit. And all those like hardware, all those processing units, microcontroller, microcomputers, or brain or control centers, they work on with the digital computer. We call them digital computers. And those digital computers, they work only on digital signals, right? So this means that even if you have a signal which is analog, like voice or anything like when you talk, any processing that is going to happen on a signal, an analog or continuous time signal, it will be converted to digital signal, be processed by the computer controller, and then will convert back to the analog signal or continuous time signal, and then broadcast or transmit to the system, right? But digital signals are so important in the like electrical engineering, computer engineering, and computer science, and any kind of the processings that we do for these signals in uh, in any kind of the hardware applications. So now we have periodic signals for both discrete time and continuous time signals. That they are signals that they repeat itself exactly after a fixed period of time. So like this mathematically, if we want to show that, we say that x of t is exactly equals to x of t plus t. So this means that you're just copying that signal over the time, okay? So, and the period of a continuous time signal, we call it t, and we normally consider that in a second. So you can see that example of a periodic signal, a periodic continuous time signal and a periodic discrete time signal, because we can have it in both ways. And you can over here, which is here we have this kind of the signal, and it will repeat over the samples. And here we have a T, and you can see that how this pattern of the signal is actually repeating over time. So now we have another concept. When you have a periodic signal, we have another concept of frequency, right? Which is the number of cycles per second of each signal, right? And it's measured in hertz and represented by F equals to 1 over T. It's actually um, reciprocal of the period. Now, when we talk about the signals, we have two main source of unwanted signals that they affect um, the quality of the original signal, right? We have noise. Noise is any unwanted signal that distorts useful information, right? So it can be like camera pixel noise, and in terms of the sensors, like lidar measurement error. Common sources of noise in autonomous vehicles or in autonomous for the autonomous transportation. Um, so we have sensor noise, we have electronic noise in circuits, like the all the electrical circuits that we have for the in the sensors and embedded systems, because all these sensors they are a part of the of an embedded system for the car or a subsystem that they may have some electronic noise or quantization noise from the analog to digital conversion. So we talked about it, like when you have a signal, which that signal is analog, and we are going to convert that to digital inside the processor, and then do the processing and analysis on the signal. So there is a term of quantization noise that's based on the quality of the analog to digital converter, and there are some concepts on that. So, and you can see that these are some like almost internal unwanted signals that we have in the signal as an unwanted signal. And why is it important? Because it can cause incorrect perception or estimation of the environment. Now, and all these signals, if some noisy signals comes to the system and goes to the controller, goes to the perception, and goes to the estimation, that will affect the control center, right? That it will affect the perception and control of the autonomous vehicle, and then affect the performance of the car. So then we have disturbance. So disturbance are some external like signals, and they are also unwanted external signals that affect the system behavior. All right. So examples of disturbances are weather effect like rain, fog, snow, road issues like bumps, like path holes, and wind forces. Okay, so if there are some like windy environment, or even other vehicles or pedestrian, like someone is running in the middle of the road, or like some other vehicle with the you may have experienced that come to the road with like um, some speed which is not regular speed or accepted speed in the road. So these are unwanted signals, and this disturbance is even it's not just affecting autonomous vehicles. So I want you to think about that. Like you have been in an airplane, right? So there are so many like in some areas when there are really huge wind, you may have observed some turbulences or some oscillations in the airplane as well. So that is where we call them as some disturbances, that they are external signal or influences that affect the system behavior. And again, disturbances, they can degrade the control system performance. So both noise and disturbance in the system, they are happening, right? It's like something that when we would say that the weather effect, so when when people design an autonomous vehicle, it's not feasible, or it's not logical to consider it only working in a certain temperature without any weather effect. So all these aspects of disturbances and noises that comes to the system, they need to be considered. And we have a concept of robust control or disturbance rejection or noise rejection or filtering in the system, or using like some certain equipment, high quality equipment that reduces the effect of noise and also compensates the effect of disturbance. So this is what we have: certain event control structure, which we call it closed loop control or feedback control, that we gather information from the environment and we sense those information, and those information is where that they got affected with one of these like rain, fog, snow, like bombs, and in a control in the brain of the car. So there are some approaches that we can use to reduce the effect of that. So it's difficult to say that to remove the effect of all these disturbances, even in an airplane, which so many like sophisticated control approaches have been used, but it's still it's you observe the turbulence in the like in the you may experience that. So we cannot say that you can remove the entire effect because even it's an uncertain uh, procedure, uncertain effect because grain can be so heavy or it can be light, so you cannot like expect the behavior of that external uh, signals, right? So now these are everything about the signals that we define the signals, types of the signal, continuous time signal, discrete time signals, digital signals, and then some unwanted signals. So when we talk about the signals, they are where that they come from the system and from they gather information, some source from the information, and we work with those signals. Now, then we talked about the noise and disturbance. They are unwanted signals that affect the system performance. Right? Now, these are just signals. Then we want to see what is a system, right? So a system is a set of connected components and they're highly integrated together. The system takes some input signal and work on it. The signal goes into the system. It actually acts, it does like some actions based on what's going on, how these elements they are connected together, and it will generate some some output. Okay. So um, a light switch is a system. So you turn the light on or off, right? And the output is the light. Okay. So the light intensity that comes from the light bulb. A volume knob is a system. So you can make the signal louder or or quieter. So a camera signal receives the light and then produces an image. Okay. This is what a system is. Like a toaster is a system. So you put the bread in and you turn it on and it will have some toasted. So in engineering, we show the system as a block and which receives some input signal and generates some output signal. All right. Now, in in autonomous vehicles, we have different kind of the system. We have perception system, we have control system, we have communication system, and we have planning system. So these are some examples of what we have in an autonomous vehicle. So they are connected together. Now, like some simple examples like a light or a toaster, they are they have very simple. There's only one. You have input, you have a timer, the input goes to the system and it generates some output. But when we have a much more complex systems, such as autonomous vehicles, even you can see over here that we have we have multiple systems. So this is what we have a definition of interconnection of systems. So what does that mean? This means that a whole system is made of really a small inter systems or that we call them subsystems that they are connected together in a way that, like for example, the input of system one goes to the output of the output of system one goes to the input of system two, and then they connect together. Eventually, the whole system will will achieve some certain mission. Like for example, assume that for a car, right? So we have a mechanical part, we have a like sensor measurement, even the right like the cars that not autonomous vehicles, a regular car, like it has a back camera and like you have a gas pedal, you have the like brake system. So then there is a perception, a human looks at the environment as a main controller, makes a decision, and once you take the action of the car, so then you push the pedal as input, the car will move. The speed of the car is going to be the output. But there are so many components in the system that they are connected together in order to have to generate that output. Now, the output for you, like you can consider it that you want to leave campus and then go to the shopping center, go to your house, go to like your work, all right? So that is where so you define a mission for the system, and then the system, all those subsystems, interconnected subsystems, they will work together and then reach to that point. So, like aircraft, another example, we can say that like an aircraft has aircraft dynamics, sensor, digital autopilot, and actuators, right? That eventually will help in working on that digitally controlled aircraft. And like sensor in that example measures the aircraft's motion, autopilot processes the sensor information and sends the commands, and an actuator adjusts the control surfaces to control the the aircraft. Okay. Now we have uh, different kind of the connection between subsystems, right? So that we call it like, for example, series. So system one and system two, they are connected in a way that output of one system goes to the input of the other system. So this is what the overall output is going to get affected based on the input that you apply, and it will generate the output. Or we have the parallel interconnection that you apply an input to two systems, and then the output of both systems will be added as the output of that. So this is where you gather information like for an autonomous vehicle. So you can think about it in a way that you gather information from different sensors and then send those information for your processor for the uh, for the processing, analysis, and decision making. So then we have another configuration which is called the feedback. The output of the signal goes to the input of the other. And then you can have a combination, have a much more complex interconnection of the systems of series, parallel, and feedback configuration, and then connect them together. Okay. So that is how we have it. We have an interconnection of the system. So this is mainly about those kind of the introduction which I wanted to cover in this lecture. That getting familiar with the signals in the next lecture when we're going to talk about the sensors. That those sensors are actually a kind of the system, which one they are a system. They send some information to the environment and then receive it back. And then how those systems, they are in an autonomous vehicle, they are connected together as an interconnection of systems and affect the control and performance and decision making of the system. So that is where we'll cover in the next lectures of the sensor and on the control system. So This is all for this lecture. So mainly there is a book of signals and systems. You can refer to that. And yeah, that is all for this lecture. And I hope you enjoyed it. And we will talk about the signals in the next lecture.